And there's three main ratios that you should be aware of: the sine, cosine, and the tangent. Okay, and all of these are based off of taking some right triangle, assigning one of the acute angles to be what's called theta, so just the angle that you're evaluating, and then referencing the ratio of the parts of this triangle based on whatever sine or whatever trig ratio you're looking at. Okay, and the trig ratios are based on the legs that are either opposite or adjacent to this given angle. So here this would be the opposite leg and the adjacent leg and the hypotenuse of the triangle. So it's referencing the ratios of two particular sides of this triangle. Okay, and the acronym for helping remember which ratios belong to which trig function is what? Sohcahtoa. Okay, Sohcahtoa. Okay, so what this shows is that the sine ratio, the S, is equal to the ratio of the opposite leg over the hypotenuse. Okay, so in any given right triangle, the sine of some angle tells you what the ratio of the opposite leg is to the hypotenuse. For a cosine, it's AH. A is adjacent over hypotenuse. And for tangent, it's the ratio of the opposite to the adjacent. So opposite over adjacent. And now remember, okay, these aren't referred to as sin, cos, and tan. Okay? This represents sine. And the sin, this, when it's written sin theta, it's actually pronounced sine of theta. Cos is pronounced and stands for cosine. And then tangent, tan refers to tangent. Again, I may say tan, okay, the tan of whatever, that refers to tangent. But everything else I'll say the sine of and the cosine of to indicate those particular ratios. Okay. So the way that these wind up working is if I gave you, or let's say we took a right triangle, okay, and you had sides of 3 and a hypotenuse of 5, and I told you this was your angle measure, or angle, theta. Okay, which trig ratio is related in this image? You have an angle, you have a leg of 3 and a hypotenuse of 5. So is the leg the opposite or the adjacent side with this angle? It's now adjacent to it, right? Because I moved the angle. It's the leg adjacent to it. So which trig ratio relates adjacent and hypotenuse? The cosine, right? The adjacent and hypotenuse is cosine. So we could say, based just on this picture, that the cosine of theta is equal to 3/5, okay? Or 3 over 5. Okay, now, what if I asked you to find the other trig ratios? What would the sine of theta be? How can you do that? Is there any way that you can identify what the missing length here is, this opposite one? Okay, good. So you're either going to use Pythagorean Theorem for this, or if you are familiar with common triples, I know Mr. Dobler probably emphasized those last year, right? Okay. Common triples, 3, 4, 5, and 5, 12, 13. They show up on the SAT quite a bit. It just, if you use Pythagorean Theorem here, and let's say this was, we'll call it x, but x squared plus 3 squared equals 5 squared, and you work to solve for x. When you subtract 9, you get 16, and what you're going to find is x is equal to 4. The common triples are just the integer triples that are common sides of triangles. So a 3, 4, 5, if you recognize that, it allows you to find the measure quickly. But if not, you just need to use Pythagorean Theorem to solve for those. Okay, once you have that missing side, you can then identify the ratio. So the sine ratio is opposite, which we found to be 4, over hypotenuse 5. And what would the tangent ratio be? Opposite 4 over adjacent 3. Okay, so these are the things that you guys have probably been exposed to, or you should have been both in algebra and geometry. Okay, in this course, we're going to extend it. It's not just these three, but we're also going to find the cofunctions. And the way that we do that is the reciprocals of these. And so you have the cosine, the reciprocals of each of these functions. And so the reciprocal of the sine function is the cosecant. The reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. And so I'll write these down here. So again, this is cosecant, the secant, and the cotangent. All right, these reciprocal functions here are just taking what it says, the reciprocals of those matching. So the cosecant is the reciprocal function of sine. So we're going to take the sine function and we're going to flip it. So instead of it being opposite over hypotenuse, it becomes hypotenuse over opposite. For the secant, instead of it being the cosines adjacent over hypotenuse, we're going to flip it. It'll be hypotenuse over adjacent. And then finally, for the cotangent, instead of it being the tangent opposite over adjacent, we're going to flip those adjacent over opposite. Okay? And so when you're evaluating these, we have our three main trig ratios, sine, cosine, and tangent. When you're finding the reciprocal functions, again, what you need to do is just take their original functions and flip it. So the cosecant is the reciprocal of sine, so it's a 5 over 4. Secant is the reciprocal of cosine, so it's a 5 over 3. Cotangent is the reciprocal of tangent, so it's a 3 over 4. Okay, now, the way that to remember these, or if it helps to remember, the sine and cosines, when you find the reciprocals, are changing the letters. They don't keep the same letter. So the sine doesn't keep the S. It changes to a C. The C changes to an S when you're looking for those reciprocal functions. All right, so what is the length of the hypotenuse? 10. So did anybody use a shortcut for this? Anna, what did you do?
I used the 3, 4, 5.
Okay, perfect. Okay, now, again, here's one of the things that shows up as far as the SAT goes. If you use Pythagorean Theorem, you get 10, that's okay. Okay, but if you can see that this is a multiple of the 3, 4, 5, so this is 2 times 3, 2 times 4, so this is going to be this multiplier 2 times our 3, 4, 5. It might save you some time, and the SATs will focus almost solely on 3, 4, 5s and their multiples, or 5, 12, and 13. Rarely a multiple of that, but sometimes. But usually it's a 3, 4, 5, some multiple of it, or 5, 12, 13 are the common triangles used. Okay, so when you're looking at this, once you establish that your hypotenuse is 10, now it's just a matter of using, again, Sohcahtoa. Okay, don't be afraid to write it down to help you remember. So sine is opposite, which is 8 over hypotenuse 10. Cosine is adjacent 6 over opposite 10. Tangent is opposite 8 over adjacent 6. Okay, and then the cosecant is just going to flip these. Now, before I flip them, I'm going to go ahead and simplify all of these, because what does 8 over 10 reduce to? 4/5. And 6 over 10. And then 8 over 6. Okay, so I'm going to use these now and just flip them. So the cosecant is 5 over 4. The secant, we flip this one, 5 over 3. And the cotangent, we flip this one, 3 over 4. Okay? So what this means is, like, given this triangle with sides of 6 and 8, the ratio of the opposite to hypotenuse is going to be 4/5. Right?